Hello, ladies and gentlemen. Thank you for joining me once again as we continue our look at the 2005 Fermat paper. We're on question number 13. A circle is drawn so that no part of it lies outside a regular hexagon. If such a circle does not touch all 6 sides of the hexagon, what is the maximum number of sides that it could touch? Okay. Well, let's draw ourselves a regular hexagon, or as best a regular hexagon as we can. I don't recommend that you do something like bring a straight edge and compass and try and draw a regular hexagon that's perfectly regular hexagon-y on your on any scrap paper, because you're just going to be wasting time with the construction. So I don't have a particular intuition. I think it's got to be less than half. But I don't know. Let's draw some circles. So I'd say it's pretty simple to get sort of a tiny circle tucked away in the corner. So we can definitely do 2, and our options are 1, 2, 3, 4, 5, the only possible options. But this rules out A. We can at least do B, C, D, or E. So we're getting there. Can we draw more circles that only touch certain sides? And we can't go outside, so I can't do anything particularly weird. But as soon as I touch him and then skirt away. No, it was coming in too steep. See, there I've sort of done 4, but I think that's just because I don't really have a regular hexagon. So it's clear we can get 2, and I bet 2 is probably the answer, but the question is, how can we are we just meant to keep fiddling around with this, or is there supposed to be some exactness? So I can keep drawing pictures, but without an actual regular hexagon to work with, I'm a little stuck. So, let's draw a super huge hexagon and see what's going on. Alright, so 2 is fine. Let's suppose I did get 3. So suppose we did have 3. He can't go outside, so these must be points of tangency. So let's use some circle geometry and see what we could see. So points of tangency, I always want to connect them up to the center. Now the center here couldn't possibly be at the center of the regular hexagon, or we would be touching all the sides. So what do we have here? So that gets them all at the center there. So I don't quite like those quadrilaterals. So let's cut these guys a little bit. Shouldn't this go through the... Yeah, the intersection of 2 tangent lines, we can connect that up with the center, and then we have a right angle and a hypotenuse and a given side length, so that forces these sides to be the same length, because all those are the same. So then we have side congruence, and so this angle's got to be the same as this angle, and this angle's got to be the same as this angle. So, but the intersection point of the line sides of tangency are not arbitrary. They've got to be the corners of my hexagon. So So the center of the circle must lie on, what's the word for that? Splits the angle bisectors. Angle bisectors of the tangent lines. Now, so angle bisectors of the corners of the adjacent sides it's touching. Adjacent sides it's touching. But once we have two of these, they have to hit the center of the... So as soon as we get two of them, we have to hit the center of the hexagon. And if he has to lie on both of them, then the center of the circle is the center of the hexagon. And once you're at the center of the hexagon, then since it's a regular hexagon, this is the in circle and you'd be touching 6 sides. So we can't have 3 provided that the two pairs are mutually adjacent. Could we touch 2 adjacent sides and then a 3rd additional side? So if So I have a feeling the answer is no, because the thing would go outside, but could we have 2 adjacent and then one sort of opposite to both of them? And this is becoming an increasingly more terrible circle, because I don't think it can reasonably be done without going outside the hexagon. You still have to be points of tangency, because we don't go outside. So center here is still on angle bisector, this guy, but... By the way, can I just say this is taking a little too long for question 13? I'm going to guess that the answer is 2. And I bet people who didn't actually think too hard about this question put 2, moved on, and got full marks. But we'll see. Because this is getting to be a lot of different cases and a lot of circle geometry. And I think that's not... Well, I don't know. Maybe there is a faster way to do it. But, so we still have... side length here, and then so now these 2 lengths are the same, and it's going to bisect this dude, but these guys intersect at 60 degrees, so it's going to bisect 30 degrees, and these are 120, so this is 60, so it's going to go straight through here. And that's also going to give us the center of the circle. And if you had... I suppose the only other case is you have only... If you have all 3, but that's even weirder. Touch here, and touch here, and I admit this isn't a circle at all. But it's going to be the same problem. It's going to go through... here, and the center's still going to have to be the center of the hexagon. So as soon as we have 3, we can't do it. And so if you can't get 3, no hope to get 4 or 5 or anything like that. So can't do 3, can do 2. So the answer is B, and I'm annoyed. I think this is a bad question. I mean, I'd love it if somebody had a faster way to do it, like a faster actual mathematical way to do it. Because I believe in a few, what I would say, simple design philosophies for math contest questions, and even questions when I make up exams and things like that. And I'm always of the opinion that a question shouldn't become harder the smarter you are. And this question absolutely does become harder the smarter you are. Because if you were dude who just, tried to draw a couple circles inside your hexagon and said, oh, I can't seem to do more than 2, I can't think of a way to do more than 2, I'll circle B, you'd get the right answer, you'd move on after a minute, maybe 2 minutes of drawing. But if you're someone who says, okay, I can get 2, if I can't get 3, I should be able to show that. We had to do a lot of circle geometry in some weird cases. I stopped even writing some of the proof out. It wasn't much of a proof to begin with, but I stopped even writing sentences and was just verifying it for myself. So, as an actual mathematician, when you say, oh, I can do 2, it doesn't look like I can do 3, a real mathematician says, yeah, but what if? What if there's some weird way to get that circle in there and do 3? I've got to know, because otherwise I'll get the question wrong. And so a mathematician is not settled by saying, yeah, it really looks like 2 is the only way you can do, it's the most you can do it. A mathematician wants to prove it, wants to show it. And so a mathematician, someone who's smart, someone who knows logic and says, yeah, just because it doesn't seem like you can get 3 doesn't mean you can't actually get 3. Someone who's rigorous like that is going to be burdened by having to work through these cases and eat up 5, 6, however the heck long this video is, minus the me talking to the camera and stuff. But significantly more time than someone who did not think through the problem, who is not a logician, who is not someone who is thinking logically. And I think that's bad test design. Is someone who's smart, someone who's rigorous, someone who is a real mathematician would say, yeah, but why can't there be 3? I should be able to rule out 3 and make sure there isn't some very special, very unique circle on this sort of angle, that sort of thing, that makes a particular cosine of 15 degrees, whatever, that there isn't one very special way to do it. And then you get burned for it. It eats up your time. And the answer was oh gee, I guess I can't do more than 2, so I'll put B answer. Anyway. Most of the questions coming out in the CEMC contests are not like that, so I'm thankful. This one I maybe slipped through their radar or something, or maybe there's a better way to do it, as I say, but I don't like this sort of question where you fiddle around with it and you don't think you get the answer. You fiddle around with it, think, and then realize, no, there could be exceptional, very special cases, and I've got to rule them out, or I'm going to get this wrong, and then, 10 minutes are gone. 10 minutes on an hour-long contest, or 5 minutes on an hour-long contest even. On question 13, no. All right, so I'm going to leave this question behind because it's still aggravating me a little bit. If you have a better way to do this question other than just saying, well, gee, it looks like I can't do more than 2, I would love to see it. Because maybe I'm just not thinking it through. I'm actually, no. We're just going to calm down and... I'm just going to assume that there's a faster way to do it. I'll look it up in their solutions and see if they have a better way to do it, because there's got to be. There's no way they'd make this question that hard. I just must not be thinking about it the right way. Oh well. Question number 14 awaits, and we'll take a look at that in the next video.